Hello everyone, let's welcome you all to the next session on Engineering Graphics Module 3 Sectioning of Solids. Today let's start with certain examples related with section of solids. As our first case, let's take a sectional plane which is horizontal in nature. As you can just check out in the figure that an object is given which is being sliced by a plane which is horizontal. This plane does have two features. The first feature is this plane is perpendicular to the vertical plane. Second feature is the same plane is parallel to the horizontal plane. Let's check one example related with it. A pentagonal prism of base of side 50 mm and height 100 mm lies on HP on one of its rectangular faces with its axis inclined at 45 degrees to the VP. It is cut by a plane perpendicular to VP and parallel to HP at a distance of 10 mm from the top. Draw the front view and sectional top view. Okay. So when a question of this sort is being given to you, make sure that you divide the question into three parts. The first part is how is the object being placed. Second thing is check if there is any change in the positioning of the object. Third thing is check how the sectional plane is actually acting on the object. The object given to you is a pentagonal prism of base side 50 mm. What is the height of it? It is 100 mm. Okay, so you have to place the object in such a way that it is resting on one of its rectangular faces on HP. So you have to keep the object in such a way that it is resting with one of its rectangular faces on HP. Now when you're looking from the front, you will get it as a pentagon. When you're looking from the top, you will get as a rectangle. So in order to draw that, first of all draw the XY reference line, after which go for the front view, that is the pentagon, because the side is being given. Yes, make sure you mark all the necessary points, after which please project it down. Since the height of the object is given, you can easily project the you can easily draw the top view. Now, an important thing that you have to note over here is when you're looking from the top, actually the edges A1, B2, C3 will be visible to you when you're looking from the top, while the edge E5 and D4 will be invisible. So you have to show it with hidden lines or dashed lines. Over here I have shown it with light lines. Okay, but when you're drawing it, make sure you go for hidden lines. Next, within the question again, it has been given that the object is being inclined in such a way that its horizontal axis is inclined 45 degree with VP. So you have to certainly position the top view in such a way that it is inclined 45 degree. Its axis is inclined 45 degree with VP. Okay. Then you need to project 1, 5, 2, 4, 3 directly upwards. You need to draw perpendicular lines. Similarly, project A, E, B, D and C directly upwards. And the same manner, you have to project it from this corner as well as from this corner. When you project it both from the top view as well as the front view, you will get some intersection points. After joining the intersection points, you will get the solid which is being inclined 45 degree with VP. This is the solid given. Okay. Now, you need to mark all the corners. After which, just check. When you're looking from the front, actually this side, this as well as this side is visible, while this side, that is 3 dash 4 dash and 2 dash 3 dash, will be invisible as the object is being solid. Okay, so you have to draw 2 dash and 3 dash with dashed line. Similarly, 3 dash and 4 dash with dashed line or hidden lines. Now check out this edges. All the edges will be visible to you, so you have to use solid line. While a portion of the bigger edge, that is 3 dash and 3 dash, a portion of which will be hidden one or invisible, so you have to draw it with hidden line. So make sure when you're drawing it, you have to mark these edges as hidden. Okay, fine. That I will show you in the solution, the final solution. Next, you have to go for a sectional plane which is acting 10 mm away from the top. Okay, so when you're using the sectional plane, which is horizontal in nature, it will cut the object at different points. Those points are actually these points over here, this one, and this. You have to name it, after which project it downwards as that you get the cut portion on the top view. This figure actually shows how you get the cut portion. Yes. Now, when you are drawing it, make sure after getting the cut portion, that is this gray portion, you have to show it as hashed lines. Over here I have just shaded with gray, but when you're drawing it, make sure you go for hatched lines. Okay. Then next I will just show the solution, exact solution of the problem. You can see that where all the hidden lines are there, where all the hash portion is there. In fact, within the question it was being told that you need to draw the front view as well as the sessional view. So these are the figures that's being drawn after attempting the question with a step-by-step procedure. The front view and sessional top view was the requisite. So you have finally met what is actually needed. Okay. Now, there's an exercise problem. Problem is about a cone base. Please read through the problem and do it. It is similar in nature with the above problem. So follow all the steps and please make sure you attempt that question. Now, next case is in regard with a sessional plane, which is vertical. You can see an object is given and that object is being sliced vertically, and the features of this vertical plane is that it is parallel to the vertical plane and it is perpendicular to the horizontal plane. Okay, just check out this problem. A cube of 30 mm edge rests on HP on its face is that one of its vertical square faces is inclined 30 degree to VP. A sectional plane perpendicular to HP and parallel to VP cuts the cube at a distance of 10 mm from its vertical axis and in front of it. Draw its top and sectional front views. The vertical center line is 30 mm from the VP. So the given object is a cube. Again, they're just given 30 mm and is being told the exact positioning of the object is in such a way that one of its square faces is inclined 30 degree with a horizontal plane. Okay. Now you need to check the positioning of the sectional plane. The sectional plane is kept in such a way that it is 10 mm in front. So before you draw the top view of the object, make sure that you draw it in such a way that the object's center point is 30 mm away from the vertical plane. That I will show in the next figure. That is, you keep the object in such a way that if suppose there is a vertical plane over here, the object is inclined 30 degree with the vertical plane. Moreover, the center of the object is 30 mm away from the vertical plane. So when you're looking from the top, you will get this figure. When you're looking from the front, you will get it as a rectangle. Okay, so project that. After drawing the XY reference line, please draw the top view, mark all the corners, then project it upwards as that you get the front view. Make sure you mark all the corners of the front view also. Now place the object in such a way that the object is 30 degree inclined with VP. Again, the object center point of the object is 30 mm away from the reference line or from VP. Okay. Now go for a sessional plane which is in 10 mm away from the center point. So you use a sessional plane in such a way that it is kept 10 mm away from the center point and in front of it. Now after using the sectional plane, you can see this sectional plane is actually perpendicular to the horizontal plane and it is parallel to the vertical plane, and this plane is actually cutting the object at two different points. Rather, this two different points has to be projected upward such that you get the cut portion in the front view. Okay. Now as you can see in the final solution, this is a sectional plane. It is after using the sectional plane, you are getting E and F. The same E and F has to be projected upward. to the front view, where you'll get it as E dash, E dash, F dash, and F dash is the cut portion. Please make sure that you hash it properly. So this gives the final solution of the cube problem. Now, try this example related with a pentagonal pyramid. Again, over here also the sectional plane is perpendicular to HP and parallel to VP. So try this problem. So let's now see you in the next session. Thank you.